In the previous sessions, we have discussed the Fourier series expansion of a 2 pi periodic function. Now we will extend this expansion to a general periodic function. Okay, so the Fourier series expansion of a 2 periodic function was, if you remember, it was f of x is equal to a naught plus sigma n is equal to 1 to infinity, okay, a n cos nx plus b n sin nx. Okay, now we will extend this definition to general periodic function. So because mostly in applications our functions need not be 2 pi periodic only, it can be in any period. Okay, so I'll extend this expansion to a function with a general period. I'll take the general period as 2l. Okay, so that we have a parity between the formulas of a 2 pi periodic function. Okay, so that is why I'm taking the interval as 2l. For example, we will be asked to expand f of x is equal to maybe x in the interval minus 1 to 1. Okay, so I'll take my 2l as the length of this interval. The length of this interval is actually 1 minus minus 1, which is actually 2. Okay, or they will ask you to expand x sin x in the interval 0 to 4. Okay, so in this case the period length is actually 2l, so this is actually 4 minus 0, which is 4. Okay, so that is how what I'm going to do. I'll take a general periodic function and we'll discuss the expansion of that periodic function. Okay, so now let us basically discuss the setting here. I am taking a function f of x. Suppose it has period 2l, okay, where it is defined in the interval d to d plus 2l. Just like our earlier f of x was defined in the interval c to c plus 2 pi, I am taking a general periodic function f of x with a period defined over the interval of length 2l, which is d to d plus 2l. Okay, so what I'm going to do is that I'm just making a variable change here. I'll just convert this variable x, which has period 2l, to a variable z, which has period 2 pi. Okay, so I'll just make a variable change here. I'll change this variable x, which has a period 2l, to a variable z, which has period 2 pi. So how to do that change? It's very simple. Now x has length period 2l and I have to change x to z, which has period 2 pi. Okay, this derivation is not required for it, but it is very easy that I'll just take x by z as just 2l by 2 pi, or I'll take x is equal to zl by pi, or I'll take z is equal to pi x by l. That is my change. Okay, so if I take z is equal to pi x by l, now z would be a variable with period 2 pi and x is a variable with period 2l. Okay, so that's the idea here. Okay, so what I'll do is that I'll take my f of x. Okay, now that is x is equal to zl by pi, so it will be actually f of zl by pi. Okay, now you can see that this is some function with which is a function of variable z. So this is a function of variable z, and z has a period of length 2 pi. So we know the Fourier series expansion of this f of z. What will it be? It will simply be a naught plus sigma a n cos n z plus b n sin n z. Okay, so this is the Fourier series expansion of f of z, which is actually the f of x only. I have only changed this x to this z variable. So this is the Fourier series expansion of f of z. Okay, so the Fourier series expansion with x would be, the variable x would be simply, it will be a naught plus sigma. I now I'll change back this z to x. So a n into cos n, your z value is pi x by l, so it is x n pi x by l plus b n sin n pi x by l. Okay, so this is the Fourier series expansion of a general periodic function. It's very simple. Okay, what I am doing here, I change this variable x to a variable z with period 2 pi. Okay, so I had a variable x which had a period of interval 2l. I'll change this variable to any z with interval 2 pi by simple substitution. That is, I'll just take a ratio, so it will be x by z is equal to 2l by 2 pi. Okay, so from this I'll get my z is equal to pi x by l. This derivation is not required for you. I'm just motivating how this formula is coming. It's very simple. Okay, so what we said that, so I'll take this f of x. Now f of x could be written as f of zl by pi. Right, now this is a function of z, so I'll just write some, this is equal to some capital F of z. Okay, now this function of z has period 2 pi, so it has a Fourier series expansion of the form a naught plus sigma a n cos n z plus b n sin n z. Okay, in this expansion I'll give back the value of z, which is pi x by l, so it will become a naught plus sigma a n cos n pi x by l plus b n sin n pi x by l. Okay, so that is the formula of a general periodic function. Okay, so remember, suppose you are being given a form f of x. Okay, suppose it is being defined over some interval, okay, of length 2l. Always take the given interval as a interval of length 2l. Don't forget that. Suppose your interval is actually 0, 1, then your 2l is actually 1. Okay, I am taking 2L so that there is a parity in the formulas of A0, AN and BN. Okay, so take the given interval always as 2L. So here your L would be 1 by 2. Don't forget that. Okay, now what is the formula? Therefore, the Fourier series expansion of f of x is equal to A0 plus sigma n is equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L. Okay, so the derivation is not required for you, but it's very simple. So this is the same approach I have done earlier also. What I'll do is that I'll change this x of in length to 2L to a variable z of length 2 pi. So the basic change of variable here is actually I'm taking x by z as L by pi. Okay, or my x is equal to zl by pi, or my z is equal to pi x by L. So that is what I'm doing. That's how I'm changing the variable here. Okay, so if you use this change of variable, the formulas of A0 also will be varied. So the formula of A0 would be 1 by 2L integral d to d plus 2L, the given interval, f of x dx. Okay, so that is also occurred by changing the formula of z. Okay, here in the formula of z, A0 would be simply 1 by 2 pi integral c to c plus 2 pi f of x dx. So when you change the variable, this will happen. You can just verify, but it is not required for you. If you want, you can just verify. That is how this formula is coming out. Okay, and similarly the formula for an also will be similar. It will be 1 by L integral d to d plus 2L, just like the earlier one, f of x into the coefficient of an, which is cos n pi x by L dx. Okay, similarly, can you just tell me the formula of Bn also? It's very simple. Bn is equal to 1 by L integral d to d plus 2L f of x into, now the coefficient of Bn is sin n pi x by L dx. So this is the formula for a general periodic function. So you can see that why I am taking the given interval as length 2L, because this A0, An and Bn are similar to that of our original periodic function of period 2 pi. So in those cases, instead of L you had pi. Okay, so to preserve parity, that's why we are taking the given interval as length 2L. So always remember that you are taking the given interval as an interval of length 2L. Okay, so this is, I hope it is clear. So this is the method here. So the general this is the formula for a periodic function, and the rest of the conditions like the Dirichlet's conditions, everything will be the same only. That means the function should be finite, and there should be finite number of maxima, minima. Okay, so those conditions also will be applicable here, and also this expansion will be valid for all points where f of x is continuous, and for all points of discontinuity it will be actually the average of left and right hand limits. So all those conditions would be holding here also. So same thing only thing is that your nx would become n pi x by L. Okay, so remember this thing. So this is the case for a general periodic function. Okay, again the questions which will be coming from this section is that you will be given a function, you will be asked to expand it. So always remember the given interval length should be taken as always 2L only. Okay, so you have to remember that. Okay, now let us do the problems here. So let us now obtain the Fourier series expansion of f of x is equal to pi minus x by 2 for 0 less than x less than 2. First step, the given interval length is taken as 2L. What is the given interval length? The given interval length is 0 to 2, so it is actually 2 minus 0, which is 2. Okay, so your L is actually equal to 1. So this is your first case. Okay, so what's the formula now? The formula is f of x is equal to a0 plus sigma n is equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L. Okay, in some textbooks they have also used the formula a0 by 2, just like the pi periodic case also. So if you're taking the formula a0 by 2, accordingly your a0 will become 1 by L. Okay, this is also similar to the one in the case of 2 pi periodic function also. Some textbooks use the formula a0 by 2. So ultimately everything is just the same only. So be careful which formula you are using or which textbooks you are using. You can use either formula. So that accordingly you have to make the change in the formula of a0 also. Okay. So this is it. Now let us try to expand it. So you know the formula of L is actually 1. So this will become a0 plus sigma n is equal to 1 to infinity an cos n pi x plus bn sin n pi x. Okay. Now it will be just straightforward calculation. What's your value of a0? Your a0 is equal to 1 by 2L. So it will become 1 by 2 integral given interval 0 to 2 pi minus x by 2 dx. Right. So this is actually 1 by 4, so it will become pi x minus x square by 2 in the interval 0 to 2. Okay, very straightforward calculation. You just complete it. I have written it in the next slide. So this is it. Now how will you find an? Similarly, an would be actually 1 by L. So it is 1 by 1 integral given interval which is 0 to 2. Okay. Now pi minus x by 2 into cos n pi x by L. So here it is cos n pi x by 1. Okay, so it is just cos n pi x dx, or it is actually 1 by 2 into integral 0 to 2 pi minus x into cos n pi x dx. Okay, now you can apply integration by parts here, so it will become 1 by 2 pi minus x into, again, sin n pi x by the real factor of n pi minus pi derivative of pi minus x, which is minus 1 into, again, derivative of sin n, integral of sin n pi is minus cos n pi x by n pi the whole square in the limit 0 to 2. Okay, so this will become this will become, now apply this limit here. So basically when you apply 2 here, it will be 1 by 2 into pi minus 2 into sin 2n pi. So sin 2n pi is 0, so this will become 0. Again here it will be, when you apply here it will minus, so it will become minus cos 2n pi, which is 1, so minus 1 by n pi the whole square. Again when you apply 0, this will become 0, this will become again 1 only, so this again will become plus, okay, because it's lower limit, so it will become plus 1 by n pi square. So I'll think the value of a naught is actually 0. Okay, similarly you can find the value of bn also. Okay, so this is the formula here. So the value of a naught was 0. Okay, a was 0. Well, if a naught according to us, it should be pi minus 1 by 2, because you have used this formula, which was a naught is equal to 1 by 2L formula. So for us, when you do it in our way, it will be 1 by 2. Okay, similarly you can apply the formula for bn also, the same idea only. So this is actually pi minus x into minus cos n pi x by n pi minus, so they have used the old formula. You can use the general formula also. In that case you will be getting n pi. Okay, so when you use the general formula for us, as our case, it will be remember it is actually integral 0 to 2 pi minus x. Okay, so I will take 1 by 2 outside, pi minus x into sin n pi x dx. So when you integrate, what will you get? It will be actually pi minus x into minus cos n pi x by n pi minus derivative of pi minus x is again minus 1. Okay, minus 1 into, again, minus sin n pi x by n pi the whole square. Okay, so minus 1 into minus sin n pi x by n pi the whole square. In the limit, you have the limit as 0 to 2. So when you apply the limit, what will happen? So 1 by 2 is outside. So when is 1 by 2 outside? So it will become 1 by 2 into, okay, so it is becoming 1 by 2 into, okay, so it is pi minus, so it is minus of pi minus 2 into cos n pi into 2. So to cos 2n pi, which is multiple of 2 pi, so it is actually 1, so it is by n pi, so it will simply become n pi there. Okay, and again sin 2n pi is actually 0, so it will become 0. So now when you apply 0, you will be getting it as just pi, so minus will become minus pi, so but lower limit, so it will be just plus pi. Okay, plus pi by n pi. Okay, so from here I think you will be getting the value as my 2n pi plus 3n pi. So it is actually so here I will be getting it as so when you apply the limit of pi also, it will be actually pi by n pi will be there. Here it is actually minus pi, so pi will be getting cancelled out, so you will be getting just 2 by n pi there. So 2 by 2 is there, so you will be getting the values just 1 by n pi. Okay, so that is the value of your bn. So only please write with me, only then you will understand. If you just listen, you can understand. So it's very simple. You just try to do it yourself, only then you will understand. Okay, so when in these formulas, always you will have some factor of this n pi x etc. when you integrate. So don't forget to put that factor there. Only if you do more problems, you will understand. Okay, so please try to do that also. So the final answer is actually pi minus 1 by 2. This was for a naught plus 1 by n pi into sin n pi x. Okay, so that is the formula. Okay, we will do one more problem. It's very simple. So again, let us find the Fourier series expansion of f of x is equal to x minus x square for minus 1 less than x less than 1. As I told you, the given interval is taken as 2L. Okay, so the given interval here is length is actually 1 minus minus 1, so it is 2. So the value of your L is actually 1. order number that. Okay, now what's the expansion? Your expansion is f of x is equal to a naught plus sigma n is equal to 1 to infinity a n cos n pi x by l plus b n sin n pi x by l. Okay, now since this is the function x minus x square, you can use the properties of odd or even functions also if you want to simplify it. Okay, so what's the value of a naught? A naught is actually 1 by 2l, 1 by 2 actually, because l is bound in the interval minus 1 to 1 x minus x square dx. Okay, so if you write this, this will be actually 1 by 2. Please do it with me, only then you will understand. So this is actually 1 by 2 into 2 times integral 0 to 1 minus x square dx. Why? Because I have used the property of even functions here. So in minus 1 to 1 x is actually 0 because x is an odd function, and minus 1 to 1 x square will be 2 times integral 0 to 1. So if you want, you can do it like that also, or else you can do it directly also. It's your choice. Okay, so this will become simply minus x cube by 3 in the limit 0 to 1. So this is actually minus 1 by 3. Okay, or you can do it directly also, that is here it will be 1 by 2 into, if you do it like this, x square by 2 minus x cube by 3 in the limit minus 1 to 1. So when you substitute also, you will be getting this value. Okay, so that's it. Okay, so I hope it is clear, minus 1 by 3. Okay, again, how will you find the value of your an? Your value of an would be, write down the formula, it is actually 1 by l. So please write with me. So it will be 1 integral minus 1 to 1 x minus x square into cos n pi x by l, but your l is actually 1, so just cos n pi x dx. Okay, so this, if you want, you can simplify it like this, minus 1 to 1 x cos n pi x dx, or you can do it directly also, no issue, minus 1 to 1 x square cos n pi x dx. Now this is an odd function because cos is even, x is odd, so this value will be 0. This is an even function because x square and cos are both even, so it will be minus 2 into integral 0 to 1 x square cos n pi x dx. Okay, now you can use that your integration by parts, that formula. So this will become, so it will be minus 2 is there outside, so it will simply become x square into sin n pi x by n pi. Okay, again minus 2x into minus cos n pi x by n pi the whole square. Okay, again plus 2 into minus sin n pi x by n pi the whole cube in the limit 0 to 1. Okay, so just do it and just substitute it. Okay, so if you do it, I will do it once again for you. So your an is actually minus 2 integral 0 to 1 x square into cos n pi x dx. Okay, because of the odd or even properties, I have simplified this one. So this will become minus 2 into x square into sin n pi x by n pi minus 2x into minus cos n pi x by n pi the whole square plus 2 into again minus sin n pi by n pi the whole cube. This is your integration by parts, generalized form, so from 0 to 1. Okay, so when you apply the formulas, when you are applying 1, it will be x square into 1 into sin n pi, which is 0, so this will become 0, so it is minus 2 into, so first term is 0. Again, if you apply 1 here, it will be plus 2x, so it is actually plus 2 into again cos n pi by n pi the whole square. Okay, again when you apply 1 here, it is sin n pi, so it will sin pi n pi, so it will become actually 0. Okay, now when you apply the value 0, this quantity will become 0, sin 0 0, this quantity will become 0 because x is there, and this quantity will become 0, so this is the final value. Okay, so the answer would be, so it is minus 4 by n square pi square cos n pi, or you can write this as minus 4 into minus 1 raised to n by n square pi square, because the value of cos n pi is minus 1 raised to n. Okay, so that's the value of an. Similarly, you can find the value of bn also. When you find bn, it is actually 1 by 1. Bn will be actually 1 by l, so it is actually 1 integral minus 1 to 1 x minus x square into sin n pi x by l dx. So actually this is the one. So this will actually become 2 into integral 0 to 1 x sine n pi x dx. Okay, why? Because x into sine n pi x would be even function, because x is odd, sine n pi x is odd, x square is even, sine n pi x is odd, so here this will become x square sine n pi x, the integral will become 0. Okay, now this, for this you can directly apply the integration by parts, so it will be 2 into x into minus cos n pi x by n pi, okay, minus 1 into again minus sine n pi x by n pi the whole square in the limits 0 to 1. So when you apply 1, it will be actually 2 into minus cos n pi by n pi. Okay, when you apply 1 here, it will be sine n pi, it will become 0. When you give 0, this first quantity will become 0, second quantity will become 0. So this is just thing. So I think it is 2 into minus 2 into minus 1 raised to n by n pi. Okay, please correct me if I am wrong. So this is the value. We have done the calculations on the next page. So the values of an is this one. Yeah, this is correct here. The value of a naught was minus 2 by 3 because they have used the formula a naught by 2. We have used the formula just a naught, so we got the value of a naught as minus 1 by 3. Both are correct. Okay, so accordingly, we have to make the change here. We had used the formula a naught plus, that is why we got the value of a naught as minus 1 by 3. Okay, ultimately that factor would be minus 1 by 3, and the value of a n also we have known here, and the value of b n also is there here. So the final answer would be, we can just write down. So it will be simply be a naught is minus 1 by 3 plus sigma n is equal to 1 to infinity minus 4 into minus 1 raised to n by n square pi square cos n pi x plus minus 2 into minus 1 raised to n by n pi into sine n pi x. Okay, so this is the formula. If you want, you can simplify it like this also. So this is the final answer. Okay, so I hope that is clear. Now we will move on to the next problem. Okay, so if you want, you can simplify it like this, or you can keep it like that itself. Okay, now we will do the next problem also. So that's also a similar problem only. So here it's a discontinuous function, piecewise defined function. So the interval is 0 to 2. So the first step, the given interval length is 12. It is actually from 0 to 2, it is actually 2. Your L is actually 1. Okay, now the formula for a naught, it is actually 1 by 2L. So it will become 1 by 2 from integral 0 to 2 f of x dx. So it will become 1 by 2 into from integral 0 to 1, it is pi x dx. Don't forget to put the brackets here. Plus from 1 to 2, it is pi into 2 minus x dx. You just substitute the values, you will be getting the value of a naught. And similarly for n also, you will have to define the integral piecewise. Okay, so that is just the way. Rest everything is just the same. Just substitute the four values, find the values of an and find the values of bn. Okay, so that's it. It's very simple. If you know the Fourier series methods of the 2 pi periodic function, there is nothing new in the 2L periodic function. Only difference is that instead of your nx, you have the formula n pi x by L. Rest everything is just the same. So study those or do the problems from n cos 2 pi. The similar concepts will come over in general periodic function also. Only difference is that instead of your nx, you will have n pi x by L factor. That's it. Okay, so this is the value. You can just check it out. Okay, so that's it. Thank you.